Alright everyone, so this is my demonstration of my FPGA project, implementing custom stochastic computing hardware acceleration, right? And here is the demo setup. We have a high definition display running 1920 by 1080p, right? And this is the oscilloscope and to measure the runtime later. And this is the FPGA. So this FPGA is currently running the RISC-V 32-bit softcore processor at 200 MHz, along with my custom stochastic computing hardware. And this FPGA, it will pull the HDMI data and forward to this display later. So in this process, it can capture the video frame and process the image as needed. Alright, so we have two demos here. One is on CPU, running the RGB to grayscale conversion on the CPU, and secondly I will run it on a custom stochastic computing hardware. So by RGB to grayscale conversion, here is the formula, right? So this is a simple Mac operation, as you can see. So my stochastic computing hardware will accelerate the Mac operation, right? So here is the video frame, as you can see here. Right, let me start the video. Alright, let's start the video. So here it has 3 frames. First is streaming the live video from HDMI. So we have a second frame, right? This second frame, just now I've been using it for converting the grayscale image. So it's a result of the previous test. And we have a third frame which is unused, not using it, so we leave it blank. Now we go back to the first frame. So the first frame is running video right here. Okay, so if we need to start the conversion, we can, like, let's say we pause the video. Alright, and then we could like go to the second frame and we can start the CPU RGB to grayscale conversion. Let's start it. Alright, so you can see it start converting, right? And there's a signal pulling high. When the process start, the GPIO signal will be pull high. When the process ended, GPIO will pull low by the software. Alright, so you can see that it's slowly converting to RGB of the current frame. Alright, line by line. So this is the behavior of the CPU. Although the CPU is RISC-V 200 MHz. Okay, so I think it might take some time here. About, I guess, 50 seconds. Alright, almost there. So we can see, we can pause this, hold this signal when it's ended. Right, so it's ended, so we can hold the signal. Right, as you can see, the signal is holding here. Then here we could measure the runtime. Right, so it's about, if cursor A is correct, cursor A. Alright, so it's like 52.8 seconds, right? So it takes 52.8 seconds for the CPU to convert the single frame. Although the CPU has a DSP implemented, but it still takes such a long time. Alright, so now let's test with the stochastic computing hardware, how well it performs, right? We will find out. So here I continue the oscilloscope, but now I had to set the time frame to very low. Right, 1 second, not enough. It's too fast. 200. Alright, let's say 200 millisecond. So then here we continue the video. Right, let's say we go back to the current video frame and play again. So we would like to take a pause again before we continue. Alright, maybe let's say we take a frame. Okay. Okay, no problem. I take this frame, and then let's say we go to the second frame. Right, so this is a grayscale image converted by CPU just now. Now I would like to start the stochastic computing grayscale conversion. Right, it will be very fast. Right, let's say I press enter and pause. Right, it's done. Right, so the grayscale conversion has been done by the stochastic computing hardware. So this is how much time it takes to complete the process. Right, I think let me zoom in a bit. Yeah, zoom in a bit more, bit more. Right, it's fine. I adjust the time. Can you see that? Right. Adjust the time. Okay. Right, and the cursor B. Cursor B. Right. Be patient. We get the result. Okay, so this is like 34.4. Right, so it's like 34.4 milliseconds. So it only takes milliseconds to complete the Mac operation, right, of this million pixels, right. So this is how fast the stochastic computing hardware, which is running on is a highly parallel implementation here. So so this is how fast is the stochastic computing. Alright, so I think that's it for the presentation for this demo. Alright, thank you for your attention.